Hi, this is Gordon Wade presenting my final project for CS89. So for this project, I've created a recommender system that gives beer recommendations using collaborative filtering via an autoencoder, and the data is provided by Kaggle. The technology I used is very standard, Python, Keras, and TensorFlow, and I have the versions listed here. I did all of my training on my local MacBook Pro setup, but I'm sure you could significantly reduce training time by using a well-equipped VM. The data set that we have is 1.5 million beer ratings provided by Kaggle.com. We focus mainly on the review overall, which is a 1 to 5 score, and then for a portion of this I use sub-scores as well. So this is based on collaborative filtering and the use of the autoencoder architecture. So collaborative filtering is a useful way to compare users with sparsely populated data and basically choose similar users in order to predict what user 1 might think of beers 3 and 4 in this diagram here. And as we know from this class, an autoencoder has smaller layers in the middle, which force a bottleneck, and that causes our model to learn some generalized features which can be applied to new data. So to skip straight to the results here, we see that we experimented a bit with different sized coding layers, and what we saw was that we have good performance in all of them, and we don't see a lot of drastic changes based on that. We do see that deeper networks tend to train a little bit faster and tend to experience overtraining effects a little bit earlier on, but that the ultimate loss that they reach is pretty similar to our simple, shallow autoencoder model. And then finally, when we train using additional subcomponents of the review, we see that it takes a bit longer to train. And our final output here is given any user with their currently reviewed beers, we can provide some recommendations on new beers that they might like.